I'm Filip, and I'm a staff Kotlin developer at TouchLab. Before we begin, let me share with you a bit about my background. It's relevant to today's talk. You may know me as a co-author of Sky, which is a Kotlin compiler and a Gradle plugin for Kotlin multi-platform, and its job is to improve the interoperability between Kotlin and Swift. Other than that, I've spent my whole developer career working for small mobile app developer agencies, building mobile apps for our clients. And due to the nature of this work, I got to work on so many different kinds of projects with different teams of different sizes, different companies. And basically, in every single time, I was working with some other technology than before. And one of the things that I frequently encountered, my job was to often deal with build scripts, build setups, improve them, and so on. And one of the build systems I'm using today still for this job is Gradle. My journey with Gradle began way back when you still had to use Groovy DSL for configuring Gradle. And I have to admit, at that time, I was completely lost. I had zero idea what I was doing. Everything felt like magic. And it was only after they introduced Kotlin DSL that things slowly started making more sense because they became more static. The IDE was suddenly able to provide documentation, code completion, navigation, and all of that. But still, the way I was working, I was just going to Stack Overflow, looking for answers, copying them, and hoping they will work. At some time later, I started working with these build scripts more and more, and I realized that like this, I can't continue working like that because it's just not possible. So I decided to take it a step further and actually dedicate some time. By that I mean a significant amount of time to learn Gradle properly by reading documentation, start testing some stuff, and over time I started like getting better and better. But it wasn't until I was forced, literally, to write my first plugin and then subsequent plugins where things finally clicked in, started making sense, because I got the perspective of the other side, the authors of plugins, the problems they were dealing with, how they are solving them, how that impacts the users of the plugins. And this brings me to the reason this talk even exists. The goal for today for me is to share with you some of those aha moments I got throughout my journey that helped understand Gradle more, that resolved some of the confusions I had and I see a lot of people have about Gradle. We will start by answering a very simple question: what is Gradle? Might seem uninteresting, but in reality it hides a very important insight. Next, we will cover some of the basic building blocks of Gradle. Though we will be just scratching the surface, Gradle is too large to cover entirely in a single talk. The entire day wouldn't be enough even. So we will just focus on these like key concepts, the things that are confusing and that are actually easy to resolve with just a little bit of time. And at the end, I want to teach you how you can debug your Gradle scripts. I think it's a very valuable skill to have, as that can make fixing your big things issues much easier. So, what is Gradle? Gradle is a build system, but you shouldn't think of it like that. Instead, think of it as a platform. Gradle on its own doesn't know how to build a project, like none of that. Like all of that logic comes from plugins. The reason Gradle exists is that it's supposed to provide the platform, the tools, the classes, functions that the authors of plugins can use and reuse to build the logic that actually builds your project. And the goal here is to just avoid reinventing the wheel every single time someone wants to build a project in a new way. Gradle gets a lot of bad reputation for being too complex, too difficult to learn, too hard to use, and so on. And I don't think that it's really like deserved, because while some of it is true, most of it really isn't Gradle's fault. It's the result of what Gradle wants to be. It wants to be a platform, something that's configurable, something that's extensible, something that others build upon. And while people would like to have a simple build system that just does the thing that they need for their project, I had the opportunity to work with many build systems, and let me tell you, this simplicity comes at a cost, and it's not always great as well. As your project grows, becomes more complex, reaches the enterprise level of size, you will start running into so many different limitations of these simple build systems that that you will have to develop crazy workarounds, and overall complexity of the build skyrockets very quickly. And worse, you can easily run into a situation where the thing you need to do just can't be done with a simple build system. So there is always its trade-off, and I think that's true for basically any technology. But speaking of complexity, when people complain about Gradle being complex, what they usually complain about when I talk to them is the plugins. And most notably, it's the Android Gradle plugin, which adds like 80% of the complexity to your entire build. Some of it is also Kotlin Gradle plugin, primarily the multi-platform part of it. But yeah, that's the point. Plugins add a lot. They add a lot of functionality, a lot of complexity as a result. One of the things the plugin add are extensions. This is the way, it's a concept in Gradle that allows the plugin developers to define DSL that then you, the users, use to configure the behavior of the plugin. And this brings me to an important point, a distinction that you have to make when working with Gradle. What is Gradle and what is the plugin and which plugin at that? So here in this example, when we have the Kotlin declaration, that's a concept, it's basically generated code that Gradle gave you based on the configuration from the plugin. But anything inside that, that's the Android Gradle plugin. So for example, if you wanted to know what this explicit API function does, what the configuration it changes, you have to go and look in the Kotlin Gradle plugin documentation, which is hosted by JetBrains, not the Gradle official documentation, because, well, this has nothing to do with Gradle itself. So we will not find it there. And the same is true for whenever you want to, for example, report a bug or look up a bug in an issue tracker. There are multiple issue trackers, one for each plugin and for Gradle itself. Same goes for communities. If you are reaching out to some community asking for a question, knowing which community to ask the question in can significantly improve your odds on getting a fast response. Another thing that Gradle adds, or the plugins add, are tasks. You've all encountered tasks if you use Gradle. It's the thing that runs and that does all the work. Whenever you press the sync button in IDE or the run button, chances are underneath it, it just executes a bunch of Gradle tasks. And this is what you see in the console as an output where the tasks run. Gradle defines tasks as an independent unit of work, which is just a fancy name for saying that somewhere in the code there is a function with some logic in it. There are a bunch of these functions, and ideally they should be independent, and that's what's a task, basically. There are many different types of tasks. Some of them compile code, some of them run tests or publish artifacts, and so on. And more generally, they transform files. And if we generalize it even further, these tasks take some inputs and they convert them into some outputs, which is true for many functions, actually. It's just that it happens that in Gradle, those are usually files. In fact, most things that Gradle does somehow involve files and the file system. And most of what Gradle is, the most significant portion of its APIs is just some way or convenient way to work with the file system. Another important feature of tasks is that they can be chained, which means you can take outputs of one task and put them as inputs of another. This way, you can create more complex behavior than we would get from a single task. And you may know this concept, for example, from Unix and the shell, like bash, where you have commands, and there is like an unwritten rule in Unix that the command should do one thing, and it should do it well. It's the same concept here. You just combine, just in Unix, you combine these using the pipe character in shell. Here, you combine them explicitly by declaring which outputs and inputs belong to which tasks, and Gradle does these connections for you. Now that we have tasks, we can look at the build lifecycle. This is one of those things that really confused me back then. And the concept is really simple. Not all the code that is part of the configuration and the plugins run at the same time. Makes sense. Some of it doesn't run at all. In fact, usually most of it doesn't, because during a build, not all tasks run. Doesn't make sense for them to do. And we can understand this better when we look at this diagram of the Gradle lifecycle. There are three main phases, and those then have independent steps in them. To make things more complicated, the plugins can also add their own lifecycle on top of that. Both the Android and the Kotlin Gradle plugins do that. But for simplicity for today, we'll just stick to the basics. At the beginning, when you run a build, Gradle runs the initialization phase. In this phase, it will look at the settings Gradle KTS file, which contains basic configuration for the build, which is like global for whatever happens. And most importantly, it contains the definition of the modules that are part of the build, which is the include function. By the way, Gradle calls these modules projects. You may also encounter include build, which is basically a way to include a sub-project into the build. And it's called a build because Gradle calls project builds to make the naming easy to understand. Once we have a definition of all the modules that are part of the build, we can move to the configuration phase. Here, we run into the build Gradle KTS files. But we don't execute them immediately. Instead, Gradle looks at the top of the file, and there is like this plugins block. This is a special treatment in Gradle. Gradle extracts it, evaluates it independently. That tells Gradle which plugins to load. It does that. It runs the initialization of these plugins in the order in which they are declared. And only after the plugins initialize the DSL and all of that, Gradle takes the rest of the build Gradle file, basically wraps it in a function and evaluates it top to bottom. With that being done, the plugins can now react to whatever configuration the user did and finalize it. That's usually done using things like the after evaluate function. What this function does, probably you've encountered at some point, it means after the files are evaluated. That's basically it. With the configuration being finalized, Gradle creates a task graph, which is a structure that contains tasks. And it's a graph because there are dependencies between these tasks that determine the order in which these tasks get executed. An interesting property of this task graph is that not all tasks that were available during configuration are in there, only those that will be later run. Next, we move to the execution phase. Here, Gradle takes the tasks one by one and executes them in the order determined by the task graph. Sometimes, if this feature is enabled and if the tasks are independent, Gradle can run them in parallel as well. Another feature you for sure encountered if you use Gradle are dependencies and dependency management. It's a sort of more abstract concept than you are used to from other package managers. It's a general way to provide some external resources to a project. Usually it will be just regular libraries, dependencies in the form of jars, but for Kotlin multi-platform, it can be klibs. Or it can be a native binary for a native language. But Gradle also uses this for its plugins. The infrastructure for loading and plugins and handling them is the same. So if you ever had to do some advanced configuration for plugins, you will notice that the APIs for that looks surprisingly similar to declaring regular dependencies. That's by because they are basically the same API underneath it. And you can also share source code, which is a common way to do that in JVM ecosystems. You just wrap it in a jar that has the sources. But you can also use this for any other kind of file, like text file, binary file, doesn't matter. It's up to you. All of this is built on top of Maven. So you will, if you know Maven, you will run into many similarities. That's because the core underneath it is just Maven. And Gradle decided to add a bunch of functionality on top of that. And I should warn you that if you decide to learn Gradle, expect this to be probably the most difficult part you will encounter. That's not because Gradle made it complicated. It just turns out that dependency management in general as a concept is a surprisingly difficult problem for any package manager. Let's now look at some build optimizations. If you've ever used Gradle, you probably know that the builds can sometimes take a while. which is a problem for a build system whose primary job is to just compile your project and do it as fast as possible. And obviously, the authors of Gradle are aware of this problem. So over the years, they added a bunch of optimization features to speed things up. And I want to share some of them with you today because they impact the way you use Gradle. The first one, Gradle daemon. Gradle is a regular JVM program. It's written in Java, partially in Kotlin. That means it suffers from some of the disadvantages that JVM programs have, and that's that their startup takes a while. And that's, again, a problem for a build system because usually the way you use it is you want to build your project, so you start the process, it compiles your code, then it terminates, and then later on you do that again. And if the builds are reasonably fast, which we want to have them, then the startup cost can be quite a significant portion of it. But worse, we also have the JIT, which optimizes code for JVM. This runs at runtime, and it takes a while for these optimizations to kick in. So initially, everything just runs way slower. And worse, the way it works, you have to provide at least time right? So then it also takes some time for this to pay for itself. The solution to that problem, well, we have human maternity in the ecosystem. Gradle is the only one using this. They're working on our house. Therefore, if you are reporting, most likely are using. And the concept is simple. If the problem is that we are starting this computer process all the time, they just keep it running. And that means we start it once, and then subsequent build will reuse that. This works using this client-server architecture. Imagine it like this. What previously was the process you interacted with now sits in the background. You don't see it. Instead, the CLI or the IDE connect to this server in a separate process, and it will send these jobs that you queued to that server that executes them for you. That way, the server will run for a long time. And you've probably seen something like this after you, for example, restarted your computer and you were asking, why does this first boot take so much longer than you are used to? First problem is really this daemon takes a while to start up, but half a second isn't that big of a deal. The JIT plays a bigger role though, because especially for the Kotlin compiler, like it really can take maybe twice or 3 times as much time for the initial compilation to run than the subsequent builds. And if you're a small enough project, then the compiler will take like 3-4 runs before it's fully optimized. Then we have incremental builds. The point of these incremental builds is that we don't always have to do the same amount of work every single time if we've already done it in the past. And in builds, oftentimes these tasks will have the same inputs because not everything changes across builds. So assuming we have the same inputs and assuming the tasks are deterministic, and they really should be, then they will produce the same outputs, and therefore we can skip them because it makes no sense to do the same work over and over again. You might have seen this in the console. It looks like this, where we have this up-to-date message. That's exactly it. That Gradle telling you that this task was skipped because we've already done it in the past. And we can build on top of this idea with the build cache. And it's exactly the same concept, except taking it a step further. Imagine this. The incremental build works this way, where you have a build directory, and all the outputs of these tasks sits in this build directory. But what if you compile your project, then decide to do some change, you run the project, you don't like the change, and you revert it back. Now the incremental build will not work because you overwrote the artifacts in the build directory. With the cache, this is no longer a problem because the cache is stored elsewhere, outside of the project, and Gradle can load the artifacts back into the project from this cache. And this is not a matter of time only, it's also across space that sharing works, because you move this cache from your machine to a server, and suddenly you can share this cache across multiple machines, which is particularly useful for CI builds, where, for example, if you're running tests in them, then you don't want to necessarily compile the app on each of those machines. You can do it only on one and then share it. But there are some downsides to this feature, so it needs to be manually enabled, and you have to carefully consider if you want it. First of all, it takes more disk space to store all these previous artifacts, which especially recently became quite expensive. But for the remote cache, you also need to do a bunch of configurations, setting up the server. All of that is work. Sometimes it's not worth doing it. We also have a different cache called the configuration cache, which solves a different problem of the same kind of concept. So far, we talked about the execution phase and optimizing it. We also want to optimize the configuration phase. It suffers from the same behavior that usually it stays the same across builds. So how often do you change your configuration files? It's not that often. So most of the time, you can just reuse it from the previous runs. And this is what the configuration cache allows us to do. Here I have an example from an empty project where all the previous mechanisms kicked in and basically skipped over all the tasks that we have here. So the time left is the time that the Gradle took to configure the project and realize everything is already done. It's 150 milliseconds. Doesn't sound like much, but this is a completely empty project. In reality, larger projects, this can take seconds, dozens of seconds. I've seen worse. And if you enable the configuration cache, suddenly 100 milliseconds down, and it's basically the whole cost of the configuration that you save. So depending on how long it takes, the more you save. And even these 100 milliseconds are actually noticeable in the responsiveness of the system. But that's not all. The configuration cache has other positive side effects because it puts certain restrictions on the code or the configuration code you wrote. You see, with Gradle, one of the advantages of it is that it's written in Java and Kotlin, and you can do basically anything in it. But it's also a downside because suddenly, if you can do anything, then it's basically impossible for Gradle and the tooling around it to reason about the configuration. Anything is possible, basically. So these restrictions allow Gradle to perform optimizations that it wouldn't otherwise be able to soundly do. So for example, what we get is Gradle being able to call tasks in parallel if they are in the same module. Without this, it can do it only from tasks from different modules. And because the builds usually get sort of stuck in a single module running a bunch of tasks, and often those are parallelizable, this single optimization can actually be more impactful than the savings from the configuration cache. And this feature also needs to be manually enabled, this time for a different reason. There isn't really a downside except for your build having to support it, meaning you need to be careful about your configuration and all the plugins that you use must support it. But fortunately, nowadays, most plugins that you will encounter already do that. So it's usually a free thing to enable. And the last optimization I have for you today is the lazy configuration. And here we are solving a different problem in the configuration phase. Let's say that we have some configuration that takes a while. It's expensive to compute. But in the configuration, we don't really know if we actually need it because it might configure some tasks that will not get run at the end. So the configuration time on that is wasted. And in computer science, across many different fields, the way we solve this is by delaying the evaluation of such code for as long as possible because maybe nobody will use it. And in Kotlin, you will see this pattern using this lazy function. Gradle has a different function. It's a code provider. It's the same concept. It's just that the API is different because it contains additional functionality on top of the lazy function. This functionality allows Gradle to, for example, track some dependencies and do some other things. For you, you also get additional APIs like this map function, which allows you to mutate the content of the provider without first evaluating it. Similar concept to how sequences work in Java. How do you use this? Well, let's say we have some extension and we are configuring some property of it. In the past, you would write something like that. You would have some existing computation in it. And what's expensive is relative here. Don't imagine something that takes 10 seconds. That would be very bad to have. But even 10 milliseconds can be a lot of time because you will have many of these configurations for many hundreds of tasks possibly. So these things add up quickly. So instead, what we want to do we want to delay this, and we want to use the overload of this set function that accesses the provider. But on its own, this doesn't solve anything, because we also need to make sure that nobody reads the value of this property if it's not needed. And usually you need these properties to configure tasks. This is an old way of creating tasks. You just create a task of some type with some name, and then inside this block you run some configuration of it. This configuration can touch this property we've seen before, or it can do on its own something that's expensive. Doesn't matter. In any case, we don't want to do that. Instead, we want to use a newer API that's called register function. That's basically the same as the before, except imagine wrapping the create function inside the provider. And in fact, this function returns a provider of a task, not the task itself. The difference here is that this configuration will now run only after the task is initialized, which may not happen. And this brings me to a common mistake I see in many builds, many projects that I open. And this code is used when you want to configure a task from some plugin. In this case, all tasks of this type. And you want to do something in it. It doesn't have to even be expensive. We just don't want to do that. The problem with this, and why this is super bad, is that this not only runs the configuration eagerly that you have here, but it also forces Gradle to instantiate a task, which means all the lazy configuration gets run on this task, all the hard work of all the developers that configured everything to be lazy is wasted. And even worse, potentially this can propagate, because the tasks might depend on other tasks and the whole thing, and suddenly half of your build is instantiated, you don't even know how. The correct way to do that is to add this configure each function in this specific case. Now the task is not instantiated, and instead this configuration is run only after someone instantiates it. And you might be asking, why do we have an extra function call to do such an important thing that needs to be right 100% of the time? Well, the problem is that this concept of lazy configuration didn't exist in Gradle until it was too late, basically, until there was too much code in the wild, and this would be such an insane breaking change of basically every build that they decided not to do that. And instead, they just documented it, added a secondary set of APIs. So now we are stuck with that. And the sad reality is that now in Gradle, over the many years, if you see two functions which do seemingly the same thing based on the documentation, except one is much weirder than the first one, either being it in name or having it call an extra function, whatever. Most likely you want to use the weird one, because what happened is that it was added later on as a replacement for the first one, which had some problem. It doesn't have to be the lazy configuration per se, just a rule in general. So just something to be aware of. All right, let's now look at how you can debug your scripts. Here, the important thing to realize is that Gradle isn't a black box. You shouldn't treat it as one. Like any program on your computer, Gradle was written by someone. There is source code for it, and that someone had to debug that program at some point. And fortunately for us, Gradle is open source, so we can just download the sources. It's as easy as going to GitHub. Compare this to an ecosystem, for example, Apple ecosystem, where things are just built on top of closed source, and any time you have to deal with some complex issue, you go into the disassembler. It's not fun, trust me. So that's amazing about the JVM ecosystem, really. And as I mentioned, Gradle is just a JVM program, so all the skill that you have for debugging JVM code apply here, like you debug it most as a JVM program. Though there are a few caveats to be aware of. And I shouldn't say a few, because you see, like, if this was trivial, I wouldn't have this segment in my talk. So the first thing you need to do is you need to go into the configuration, run configurations in IDEA. Here, select the configuration you want to use. Usually it will be some Gradle task. Click on the modify options. You will see this pop up, find debug Gradle scripts flag. This needs to be turned on. Usually it is by default. Maybe sometimes it isn't for whatever reason. It's always good to double check that, otherwise the breakpoints will not hit. You will be super confused and waste half an hour figuring out why. So definitely check this first. Next, we need to get the source code. Here, the easiest way, in my opinion, is to just go to the Gradle wrapper properties file, where you usually change the version of Gradle you want to use. We don't want to change that. Instead, we just want to change this suffix from bin to all. This says, please download the binary plus the sources and documentation. After you resync the project or the wrapper, you will get the sources. But I mentioned before that not everything in Gradle is actually Gradle. So let's say you want to debug a third-party plugin like this Kotlin extension. If you go to the correlation in this case, there is a chance that you will see something like that, which is basically IDEA telling you, well, actually, I don't have the sources, and this is the decompiled code for you only, which is not good enough. If that happens, and it's not guaranteed, sometimes it works out of the box. But if that happens, here are a few tricks you can try to get this working. The problem really is just IDEA is, for whatever reason, bugged at some point. It's just what happens. You can try pressing the download sources button, and then you have to close this file and go to decorations again to open a new one. If that works, great. It might not. And one trick that we can try is we can locate the library that the plugin is in and add it explicitly. So I mentioned these are just libraries and they are jar files. So if you hover over the name of this class name, in IDEA, you will see the full path that's hitting a Gradle cache. Therefore, the Maven coordinates that we are interested in are part of the path. We take that and we add it as a regular dependency. I usually use some like dummy configuration because I don't want to break my build. I just want to do something, then remove it later on. By the way, this trick works for any library. Like if you just want to see some source in IDEA, just add it as a regular dependency, and usually it works fine. Now resync the project, try again. Hopefully it works, but still not. Try downloading sources again. Do this again. If it doesn't work, now it's time to go hard mode and start things like restarting IDEA or reopening the project. If that doesn't work, invalidate your caches and restart again. If that doesn't work, go through the wall, fix IDEA feature. It starts invalidating and refreshing different indices and caches, because the problem really boils down to some index in IDEA being broken, and you have to get rid of it somehow. So you just continually expose the options. Eventually, you will see something like that. I have to mention that when I first prepared this presentation, it took me like 10 minutes to get here. And when I tried it 2 days before this talk, it worked on the first attempt. So anything in between is possible. All right. We have the sources finally. Let's start debugging. I've prepared this empty project with 2 modules, some simple code. There is a function in the configuration file. I added a breakpoint. If you now press the debug button in IDEA, you will likely see something very weird happening. We stop at the wrong file, which I'm not sure if everyone ever saw, but it's definitely possible with Gradle. And this is super weird, and we have to look closely, very closely, to understand why this happens. If you look at the stack trace, we see that we stopped in the foo function apply 10, all of that is correct. We see the a variable, all of that is correct. None of it is in the other file. And the answer for this problem lies in this image. It's the class name. We see that it's named build Gradle. The reason for that is that in JVM, everything has to be loaded inside the class. So what Gradle does when it compiles a script, it wraps the script in a function, and then that gets wrapped in a class. This class name is derived from the name of the file. In our case, build Gradle. But here is the problem. In the other module, the file is named the same, and there is no global top-level package name, nothing. So there we have 2 classes with the same name, and both IDEA and Gradle are confused by that. In my case, what happened is that IDEA basically won, quote unquote, and was the one who got confused and opened the wrong file. But what can easily also happen is that the debugger actually stops in the wrong file because it thinks it hit the right breakpoint. In the first case, you just need to navigate to the correct file, it will work. In the second case, you need to resume the project. It will hit the same breakpoint in a different file again, and eventually you will get there. The problem with these workarounds is really that usually projects are much larger than 2 modules, so this gets tiring very quickly. So fortunately, there is a better fix for this. If the problem is the name of the file, just change it. it's as simple as that. Though we've created a separate problem. Now, if you're using the Gradle, it will just break. Why? Well, because there is a convention in Gradle that the build script files have to be named in a certain way. But by Gradle being configurable means we can change it as well. If we go to the settings Gradle file, we can tell Gradle, well, actually, for these modules, should be the right name of the file. If we now resync it, just works. But don't get your hopes high yet. We are still not done. We still have other things to consider. The first one is the Gradle daemon. Usually it's not a big problem, but if you are like me and you have multiple projects open at once and you hit or like pause one of the builds in one of the projects on a breakpoint, and then for whatever reason you open the other project and start a new build, even though it's different projects, the daemon is usually reused across multiple projects. And what happens is you will get a fun error message like this. Usually it has no information about what's happening, basically completely unreadable gibberish. What this means is that the front end in the other project that calls Gradle saw that this Gradle is active. It sent the job to it, but because the Gradle daemon is paused by the debugger, it can't respond. And therefore, the front end times out exactly after 1 minute. And you will get this error. And this is not really like a huge problem. You just have to unpause the daemon or just disable daemon, but I just don't bother doing that. It's just that you have to be aware of this, because if you run into this and you don't know, well, good luck finding that out. Next problem, incremental builds. If you are debugging tasks, chances are you want to run the debugging multiple times because you, for example, forgot to add a breakpoint. Well, that's what the incremental builds optimize for. So next time it will just skip over the task and your debugger will not hit. So you can do multiple things to avoid that. First one is to just use --rerun task flag when you run the Gradle. That will force Gradle to run all the tasks, basically disabling incremental builds. You can also do a clean build, deleting the build directory. You can also delete the output of the file of the task manually. Or in my case, I usually just prefer to change some of the inputs, which is as easy as changing some constant in some string that doesn't impact the current thing I'm doing. Though, be careful if you are going with the clean build project path or the delete output file path. You need to have the build cache disabled as well, because that's what the build cache optimizes for. So if you do that without it, then it will just download or like load the original artifacts back, and it will not work anyway. So what I do is I always disable build cache anytime I'm debugging something with Gradle, because sooner or later I will just run into this problem and it's annoying after a while. Same goes for configuration cache. If you are debugging configuration, well, same problem. The configuration cache will just skip over the whole configuration. So disable it, then fix your problem, then enable the configuration cache, and careful, you have to retest, because the configuration cache might not work after your changes because you broke something, and you don't know until you run the infected task, because this is checked at runtime. Well, that's everything you should need to debug your scripts. And with that, here are some closing thoughts. Give Gradle documentation a try. It has significantly improved since the time I was learning Gradle. The Gradle team put a lot of effort into it. Really, like it's now structured in a way more sensible way. There are sections with time estimates for how long things should take or how much time you should dedicate to a section. There are tutorials, there are interactive examples. And I really recommend using those, because the best way to learn Gradle is by doing. Applies to many things, but it's especially true in Gradle. This is the part that really helped me. Once I was forced to do things, that's when I learned. Another very important realization is that when you run into problems, the instinct of many people is to just go to Stack Overflow. Nowadays, just ask the AI, copy back the answer, call it done. Sometimes it doesn't even work fully and you don't know. But main problem is you are losing an opportunity. You are losing an opportunity to learn something. Because if you just pause for a moment and understood what the problem actually was about and why the given solution works or doesn't work, over time, over many debugging sessions, you will learn pieces of the system that you work with, and it, again, like works for anything, not just Gradle, that over time, you will not even realize that you no longer do that because you will see a problem and you immediately fix it because it's just second nature to you. All right, and that's all from me. Thank you for your attention. Are there any questions?
Thank you, Felipe, for pretty exhausting introduction into Gradle and all of its deep parts. So, before we get into the Slido question, let me ask first my question, because this conference is about craft over hype. So my question, based on your personal experience, do you see AI helping developers understand and optimize Gradle builds, build time, or do you see Gradle code base and the plugin ecosystem so complex that the tools like Codex or Claude Code still struggle to help developers?
Yeah, so that's a difficult question to answer for a different reason than you might expect. And the problem is that whatever answer I will give you will be probably outdated next week. Really, like, obviously, internally, we are using AI a lot, evaluating it, trying things, seeing what the limits are. And one of them being Gradle. And it's amazing to see the progress they made here because 5 months ago, like you couldn't let AI do any Gradle, like it would just end up in a disaster. And if you try it today, most likely you will get a reasonable output. Sometimes even fixing non-trivial issues that I think less experienced developers would struggle for a day, for example. So yeah, like things improve definitely. Though even today, still AI and top-level models will always do something that's a little bit off. Like even now, I'm still looking at these Gradle scripts with more carefully than other parts of the code because you will find things that aren't optimized right away. Like you will definitely found the example that I gave you with the configure each task, because the problem with AI in Gradle isn't really the complexity. It's the amount of bad code out there that AI learned from. So if every project has this bug, most likely AI will write these bugs as well. And this is where it will take a while before these things improve and AI gets better enough to understand what is correct and isn't. But still, I think learning Gradle is very important exactly because of how difficult it is and how easy it is to mess something up. And so quickly understanding what's correct and not, it's really helpful.
So it seems the Gradle caching, it's a pretty tough topic considering we have 3 more questions related to the cache. I will read at least 1 or 2 of them. In any case, guys and girls, if you have any questions related to the Gradle, please catch up Filip right afterwards. So the very first question, if there is a way how you can automatically set up some pruning mechanism for the obsolete parts of the cache. That's the first one.
Yeah, I mean, that's a favorite question. So definitely a problem we all struggle with. It might surprise you that there is actually a mechanism in Gradle that deletes most of the garbage. After about a month, I think, Gradle will automatically delete things you didn't use before. But especially in my case, the problem is that if you have several projects and each of them uses different version of Gradle, then it has a separate cache for each of these versions. So you can have 5 times the amount of size of caches because you have 5 different projects, each on a slightly different version, like even a minor patch version differs. So one of the improvements to this space usage is just unify all versions of Gradle that you use to one. Then obviously you can do some manual cleanup, and I think Gradle also has something built in, but you would have to look for that. I don't use it regularly. But yeah, like definitely, like Gradle knows this is a problem, and though to be honest, at least in my experience, what's a bigger problem is the build directories in different projects. As you accumulate so many different projects on your drive, each of these build directories will contain dozens of thousands of files that are small, but still take a lot of space because that's how small files work, and it's a huge headache, and nobody's cleaning that up. So, yeah.
Yeah, and maybe the last one, maybe more philosophical. Why do you think the Gradle changing API so often? I guess it's because it's mess, but maybe you have a different answer.
I'm not sure I would say that they are changing the APIs so often. It's just that Gradle is currently quite an old technology. Like it's just that. Like over the years, a lot of accumulated, and there are so many different use cases for Gradle that you need to have a lot of APIs to cover them.